Greetings to you. Welcome to the Engineer Construction Lecture Hub. Today we are going to look at Hardy-Cross moment distribution method. Okay, Hardy-Cross moment distribution method. Now, this method is an approximate method, okay, of resolving statically indeterminate structure, okay, and this there are some parameters that we use to analyze beam structures via this method, okay, and we know that structures are supposed to maintain equilibrium. All right, structures are supposed to maintain equilibrium, so we try as much as possible to distribute and to balance, okay, in order to maintain equilibrium in our beam structure. All right, so before we get to the table, which is the critical aspect of determining the supports, the moments at the joints, okay, we need to understand some of the preliminary aspect of this method, all right, to enable us, get to the required destination. All right, so first and foremost, we look at the stiffness factor, okay, the stiffness factor. Now, this stiffness factor talks about in terms of how the resistance of the member, that is the beam member, to resist bending. All right, so that resistance to bending is what the stiffness factor talks about. So we must understand the degree of that resistance, okay, within that beam structure, because this resistance ought to enhance equilibrium in our beam structure. All right, so stiffness factor. For us to get our stiffness factor, we know that our pin, when we have a pin, okay, if we have a pin in this form, for us to get the stiffness factor of this, we know it's 3/4L. All right, then the situation whereby we have two fixed ends, the stiffness factor for this member is 1/L. Okay, and you know our L is the distance between this support and this support. The same thing, this L is the distance between this support and this support. So that is the stiffness factor when we are talking about Hardy-Cross moment distribution method. The other component that we are going to look at is the distribution factor. Okay, the distribution factor. Now, the distribution factor here talks about the distributing of these of the moments, all right, in terms of the joints, trying to distribute and balance. All right, that will now bring about the stability of that beam structure. All right, so, and for us to determine our distribution factor is a function of the stiffness factor. We must discover what the stiffness factors for the joints, okay, that will not enable us to assess the distribution factor. All right, so we take note of that. Then the third one is the fixed end moment. Fixed end moment. Now, understand that we need to know the moment that are generated at every point, every joint, every support. For example, if we have a beam of this nature, okay, if we have a beam of this nature, all right, we have a beam of this nature, we understand that at this point, something happens, something is happening here. At this joint here, the support, something